Welcome to Ask and Learn.
This is the answer to Chapter 21, problem number 5 from the Smith Organic Chemistry textbook. In this problem, we are asked to come up with the IUPAC name for these three ketones that we've been given. Okay, and so the rules for naming ketones. For A and C, the open chain ketones, we need to find the longest chain that contains the ketone and change the ending to "-one". And then we need to number that chain so that the ketone has the lowest number. Okay, and so for A, that's going to look like this. So 1, 2, 3. So the ketone's at carbon 3, 4, 5, 6, 7, 8. So this is going to be an octanone. And it looks like we have an ethyl group at carbon 5 and a methyl group at carbon 4. And so when we put all of that information together, this becomes 5 ethyl, 4 methyl, because remember, it's in alphabetical order for substituents. So 5 ethyl, 4 methyl, 3 octanone. And again, that ONE ending signifies ketone. Okay, so B is a cyclic ketone. So the rule is a little different. We just need to name the ring. And so this is a 5-membered ring. So it's going to be a cyclopentane. But again, we'll change the ending to "-one". So it's going to be cyclopentanone. And then we need to number this ring such that the ketone is carbon number 1. And then we want the substituents, the other substituents, to have the lowest possible numbers. So that is going to look like this: carbon 1, carbon 2, carbon 3. And then remember, for alphabetical purposes, we ignore tert. So the butyl takes precedence. So this is going to be 3 tert butyl, 2 methyl, cyclopent, and -one. So 3 tert butyl, 2 methyl, cyclopentanone. Okay, and then for C, we're back to an open chain ketone. C was given to us in lettering notation, so I would always just rewrite that in skeletal notation because it's so much easier to see and to work with. And so since this molecule is symmetric and it's symmetric through the ketone, we can start numbering at either side. It doesn't matter. Either way that we do it, the ketone is going to be at carbon 3. It's going to be a pentane derivative. And we're going to have 2 methyl groups at carbons 2 and 4, or rather 2 methyl groups each at carbons 2 and 4. And so this is going to be, as I said, a pentane derivative. So it'll be pentanone. It'll be 3-pentanone because that's where the ketone is. And then we just need to account for those 4 methyl substituents. So it's going to be 2, 2, 4, 4, tetramethyl, 3 pentanone. Okay, and so that's it. And these rules, if you need to review them, can be found immediately above this problem in the textbook. And that's the answer to Chapter 21, problem number 5.